I'm Varun Singh. I'm CEO of CallStats.io. We're analytics for WebRTC. We help companies diagnose and detect issues in their deployments. So we're the first cloud-based monitoring service for WebRTC. We launched about a year ago, and the last 6 months we've seen steady growth of about 25 companies signing up each month. So I'm also the co-author of the WebRTC spec. We were supposed to do an update today, but because of time zone differences and things like that, we're going to probably do an update tomorrow. So you're going to see a new version of the WebRTC statistics document roll out. The last one we did was in October of last year, so it was bringing it up to date. So why is statistics and monitoring important? Because when you do deploy WebRTC products or audio-video products, you want to know if your customers are getting the best quality of experience. And typically, when we talk about video and audio quality of experience, a lot of the times people talk about high quality of experience, and typically they think that's about high quality video and audio, which translates to sending more like bits per second. So a lot of the times when we talk about high quality video and audio, it's about throughput. But because this is real-time communication, it's not necessarily about high throughput. It's about, more importantly, it's about timeliness of getting data. So you want the data to appear or be rendered at the other end as quickly as possible. So typically within half a second at max. You don't want, if you want interactivity, you want it to be 100, 200 milliseconds. Anything more, like going up to 1 second, it's like satellite communication, and it's like a walkie-talkie situation, and you don't want that kind of thing. This graph is an example of an audio call, and you can see that for most periods of the call, it's like below the red line. But then there are like these skyscrapers that you see towards the end of the call, where the latency peaks up all the way to 3 seconds, which can have a situation where people go, hey, I can't hear you. Can you say that again? Or hello, hello. Is there anybody there? So that reduces the quality of experience for the customer. So Gameplan, typically when we talk to WebRTC or any company which has audio video in it, they say, oh, we do nothing. Our game plan is that we wait for emails from our customers to come in, and then we deploy something and do some tests and see what's happening, and get on a call with them sometimes just to figure out if it's their router configuration which is broken. Typically, they say it's someone else's problem. It's probably the internet, the service provider that's broken, the Wi-Fi access link is broken, and so if they can't figure out what it is, they can always blame the other party, right? Because it's a peer-to-peer call, it's between two people, and the guy who's complaining, you diagnose things at his end, he say, oh, everything's good, but maybe, the person that you're calling on the other side, he has all the problems, so, we need to do this diagnostics again or something else. So when we talk to these customers, we say, okay, do nothing or wait for feedback's actually not really scalable, because when things break, they'll break across the board, and at that point, getting feedback is not the best time, because that time everyone's complaining. So what you have to do is something like active monitoring. And active monitoring you can do at an endpoint. So you have like the Chrome browsers or Firefoxes or your iOS or Android endpoints, or you could do it at the server end. So where you can, if you have a media gateway or a signaling server, so on and so forth. So depending on how you deploy your WebRTC application, you can monitor at various vantage points in the network. Typically, when we talk about monitoring, people say like, yeah, okay, we can get all these stats, but what stats should we be gathering? So typically, I say there are like 3 types. If you're doing audio video, you want to get network statistics, so that you can get to know what's the throughput, what's the latency, what's the jitter, so all the good things that are related to how the network stack or how the transport, the internet transport works. But the other thing that you need to get statistics out is the media pipeline, because audio and video is being captured, it's being rendered, it's being, there's a jitter buffer, there's audio video synchronization, and you need to measure all those things to actually know if the things that you receive are actually played out or not. So that's the second step. And if you combine these two things, you get something called annoyances, which can be like, if you see pixelation, or if you see interface changes, or NATs and firewall issues where suddenly you have like a slow moving icon, you could even get user feedback from your end user, like gather that feedback and correlate everything from the network, from the media pipeline, and the end user feedback. So at CallStats.io, we looked at this problem and we said, yeah, so we collect everything from bottom up. So we get every data from every endpoint, from every middle box that we can gather data from, and we collect this in the cloud and correlate data. But when we visualize data, we do it top down. So you can see service level statistics at the topmost. When you log in, you see a dashboard which shows you time variation of the calls that were made, or ongoing calls that were made, or failed calls. So you can see variation of failures over time. You can also see call durations, total call durations. You can see average setup time. So if you, this may be dependent on the load on your service. So all these things you can look at the high level and try to diagnose what may be wrong, or if your operation's working. But when you find a problem, you drill down. So you can go down to a particular call and look at every individual bit in that call. So for example, we call all calls conferences because there may be one participant in it or 5 participants. We call it, just for completeness, we call it conferences. So you would see, like, sometimes in the Twilio case, you might just see one person. If it's a call center, someone using a mobile phone to call into a Twilio-based application, that's not a problem, because you would see a person made a call to this number. You would see if it's ongoing or not. So everything's in real time. So while the call's ongoing, we're collecting data and visualizing it. You can see what kind of end systems they're on. If they're using OS X or Ubuntu, Chrome or Firefox, Android or iOS. And to help customer support, we also do automatic diagnostics. So we look at the call as it's ongoing, and we start to like bubble up things that are going wrong with the call. So we would say, oh, we see AV synchronization off. There's another thing that we have is the timeline. In the timeline, you can see if the call's been ongoing. We can gather feedback from the end user. You can see if they were disrupted, if they had any problems in the call. So a customer service person who's responding to the end user complaints can just look at it and quickly give a quick response to what's happening on the call from a quality of experience perspective. So we have something called disruptions, which takes all the problems that an end user might be facing, and we put that on a timeline. And so it's like on the timeline you would see checker boxes, and if you see a lot of them, that means that the person had bad user experience because they had a lot of disruptions. So in this case, there's a person who's on a 3-party call, and he's experiencing bad quality of experience towards one participant, not to both of them. So that's shown or highlighted in the UI itself, so that he can quickly figure out that this person had not the best service towards one end. We also see, because we get end user input, we also see how some people try to diagnose those problems by themselves. So we see disruptions, and then we see people go like, oh, I can't hear the other person, so let me switch off my video and switch it on. We have events that the developers integrate into the system, so you can see like the disruptions and end user behavior correlate very well in some cases. So in this case, you can see all 3 people in the call are having disruptions, and what they're doing is they're trying to turn on and off their video, just in an attempt to see if things would become better. So that was a bit about how we gather and visualize information. But we've been doing this for the last 18 months. And so in this talk, in the rest of the talk, I'm going to show you a bunch of numbers that we've been collecting over, let's say, 100 million to a billion call records or events. And that's the state of the WebRTC as we see it, as we monitor our customers. So a lot of people are talking about, the calls. Are they single person calls? Are they multi-people call? How many people are typically in a call? So the biggest call that we've seen till date was a call with 120 participants. It happened once. We don't really know why, what is the reason, but we did see a single conference with 120 people in it. more regularly, we've seen about 20, 30 instances of calls which have had about 50 people in it. But typically, about 45% of the calls are just two parties. So we have these outliers where we have really large conferences, but mostly the conferences are between 2 and 3 participants. So 4 and 5, it starts to already taper. On the other hand, since we see the calls, we also measure if they fail to set up. So 8% of the calls fail to set up. And this is down from 2 months ago when we reported that there were about 11% call failures. So in the last 2 months, we've seen a drop in 2-3%. So we're under 10%, which is actually a good number now for us. And the call volume is actually increased in this period. So this actually shows that both the WebRTC and the ecosystem is maturing. So 8% call failures, where do these call failures happen? 85% of them are connectivity failures, and about 14% of them are because of get user media or some where people either fail to give access to the camera or or something went wrong. So as I said, 85% of the calls require infrastructure support. So or 85% of the calls have failure, 24% of them require infrastructure support. And this is a bit different for each of our customers. Some of them put a lot of infrastructure to support relayed calls. Some of them put too little. So what we see is the type of networks in 76% of the cases, just a stun or without a turn server is enough. But in about 24%, you will need to put in some infrastructure. And UDP is not enough because at least 8% of the calls need to go over TCP. And this may depend or vary from case to case. Because if you're an enterprise, if you have enterprise end users, then it's likely that you would need a turn server which requires TCP. Another use case where we saw is schools, as in a lot of the demographics for WebRTC apps are teenagers or which go to school, and schools have very restrictive firewalls which make it difficult for them to get onto the service. In those cases, deploying a TCP or turn TCP helps. As I said, we've seen issues with getting access to cameras and end devices. About 60% of the problems are permission related. So either the person denied access or dismissed said no, go away, I don't want to give access right now. And the other about 40% is related to device related. So either device was not found or bad settings or device was not supported. As you can see, actual reasons that you could really be involved in are about 40% of the cases. The other 60% of the case, it's about asking the question at the right time. I'll get to this when I summarize. When the calls are set up, we also know that calls drop, right? So during a call, at some point, you suddenly find yourself you're not able to talk to another person. We see about 16% of these calls drop. This number's dropped 4% since March when we presented this in Enterprise Connect. So the reasons of call drops are 17% of them are because of audio video, like one-way audio video, where you can see one person but you can't hear him, or you can hear him but you can't see him, and so on and so forth. And about 60% or 70% of it is network related. So connectivity loss, this might be where suddenly someone's in a 3G or wireless network and walks out and loses connectivity. They might be on a 3G network, go through a tunnel, lose connectivity. 13% are high delay, where we've ascertained over the last 4 or 5 seconds before the call drop, there was already high spikes in delay, resulting in loss in connectivity. Sometimes it's high loss, so this might be contention. You walk into a room where the Wi-Fi is highly in contention. There's so many people, you suddenly lose connectivity because of that, because of high losses. And in 2% of the cases, we see that people run out of battery, which is not much, but it happens. So there's call drops. So when calls drop, people also redial in. So in 26% of the cases, we see people join back. In 74% of the calls end normally. So people call up, people hang up, everything's okay. In 26% of the cases, people have to they get booted off, they come back in. 18% of the cases, this only happens once. In a very small majority, like very small minority, you have 3% where people keep dropping off and joining back in. At some point, these people give up. So like I guess 3 is the maximum we've seen. We've seen some cases where 5 or 6 times, but they're very few. So I guess most likely people give up and either move to another system or call again in a bit. So a bit about, since we measure a lot of this, we also have our own quality metrics. We also gather end user feedback. Our customers gather end user feedback, which they give to us, so that we can correlate our models of quality with reality from the end users. So in 12% of the cases, our customers report dissatisfactory quality. So in 60% of the cases, people say it's acceptable. In 28%, people say it was perfect. And in about 11%, they say, yeah, things were not that great, and please return our money, or this call did not happen, I don't want to pay for it, or so on and so forth. But we have a model which tries to correlate this, because not every end user is willing to give feedback. Typically, people give feedback when they're really pissed or they're exceptionally happy, right? And in all other cases, people just give up and say, oh, blah. So we have our own objective quality, which looks at the annoyances and the timeliness of media playback. And it tries to gauge from those timeliness metrics if the quality of experience was good enough or not. And in this case, this is overall our data set, including the ones that gave feedback, end users that gave feedback. So we see about 12% of the cases, the call was really poor. 73% the cases, the call was fair, and 15% it was excellent. But we are a bit more pessimistic, because we like engineers to work hard. So as you can see, compared to the previous one where it said 61 acceptable, we are a bit more harsh, and we actually say fewer calls were excellent. You need to put in a bit more engineering time and polish off your product a little bit more. So what did we learn over the last 18 months. So over the last 6 months, we noticed that there was an increase in get user media failures. And what we noticed was that as the apps became more popular and more end users which had not seen WebRTC before were asked a question like, give us access to a camera, and they were not prepared to or did not understand the context under which this was being asked, created attention. And typically what happens is most often people we ask for audio video simultaneously. So it becomes a bit more complicated in those cases where people suddenly said, oh, I would like to have an audio call, but I was not prepared to give access to video. And since both of them were presented in the same UI, they were more obliged to deny permission than to give permission. So one of the things that we noticed in January, February was an increase towards this end, and we rolled out basically in our newsletter, we wrote to all our customers saying that, hey, we noticed this, and I think the problem might be that you're asking for too many permissions up front. The other thing we noticed was the one-way audio video, and a simpler fix for this is sometimes to just reload the page. So we detect crashes and reset up connections. Sometimes that's not sufficient because there might be something else broken, but it's typically a very good way to mitigate situations where people spend 5-10 minutes figuring out if it's one-way audio or not, and end up refreshing the page anyway. So in summary, browsers, what we've noticed is Chrome dominates the WebRTC space. We notice also that the operating systems are matched. Windows and Mac are pretty even. Windows about 5% more. Participants are typically 2. 20% of your calls need relays. Setup times for call setup, 80% of the call setup in 5 seconds. That's good. Call setup failures are down from 12% a few months ago to 8% now. Most common reason for failure is network or ICE connectivity. 16% of the calls drop after setup, and about 24% of the calls have churn in them. So users drop off and join back in. So last few words, our main vision is that we want to tell our customers and people who do WebRTC that you want to move into a more cyclical, periodical way of gathering, diagnosing, and fixing things. Gather all the time, collect as much information, diagnose those situations, and try to fix as much as possible and deploy selectively depending on how you see behavior. It's better than trying to be reactive where you gather only when someone reports failure. So we have an announcement today. We, over the last few months, we put together some work with Twilio and integrated CallStats.io with Twilio client. We made it available a couple of weeks ago in beta to select customers who integrated it into production and said everything works. So today we are happy to announce that it's available for everyone who's using Twilio clients in JavaScript to integrate CallStats.io. We have a free developer account, which costs nothing. You don't even have to put a credit card in, and like you can gather data, as much data as possible in 24 hours. It deletes data after 24 hours, and maximum number of calls that you can monitor simultaneously are between 5 to 10. So that gives developers a nice chance to have a look at CallStats.io and see what kind of data it collects, and brings you closer to deploying WebRTC into production and doing proper customer support. Thank you. So if you have any questions, do come up and ask.